I'm Campbell Bratton.
I'm Blake Bottoms.
I'm Corbin Jones.
I'm Madeline Clayton.
I'm Olivia Belcher.
And we're the Better Bridges Bureau.
Oh, I didn't see you there. In case you were wondering, the first step in the engineering design cycle is to find the problem. Our problem was pretty simple. We needed a bridge that spanned a 5-foot gap, held 60 pounds, weighed less than 5 pounds, and could be collapsed into a 1 foot by 1 foot by 1 foot box. This was a pretty tough task. We couldn't use PVC pipe either, so we had to get creative.
The next step in the design cycle is the search for solutions. We met around the first week in Tally, got a whiteboard, and started brainstorming ideas. We first realized that we would need to figure out what material we were going to use and what kind of bridge we were going to build. We looked at 3D printing, foam, wood, steel, and then for the types of bridges we looked at arch, suspension, truss, realizing that 3D printing would provide us with the precision that we would need. Foam would be super light, steel would be super strong, and wood would be very cost effective. For the types of bridges, arch would provide us with the simplicity that we would need, truss was a very strong design, and suspension was easily collapsible, fitting the requirements that we needed for the bridge.
Next, we had to narrow down our ideas. For material, foam would not be strong enough, steel could be too heavy, and 3D printing would take way too long. So we chose wood, a happy medium. It's cost effective and easy to use. For design, truss would be too complex and not easily collapsible. A suspension bridge would not be self-supporting, so we went with arch for its simplicity. After choosing our material and our design, it was time to build a prototype.
So when we set out to build, first we had to find a place to build our bridge. We chose the craft center because of its proximity to our dorm rooms and the availability of a workshop inside. We first decided prototype to make sure our math was correct. We made a 1 foot scale model to test our angles and lengths that we had chosen, and it worked out fine. So then we went to the Home Depot, that's like 2 miles away from here, and chose our hinges and latches in order to create a collapsible system for our arch bridge. And then we just had to go and build our actual bridge, and it took us 3 work days.
All right, Corbin, where are we at?
Home Depot.
All right, what did we just buy, guys?
Hinges.
Stuff. All right, we got what we get: hinges,
Latches,
latches, screws,
the screws came with it, and some chain.
and a Reese's bar.
Yeah.
Cups, not a bar.
Lastly, we had to test and check. First, we tested the latches by compressing the individual bridge pieces to make sure they held. Next, we had to check the weight. It came in 2 pounds over, so we had to continue to drill holes in each plank in order to lessen the weight. However, we had to test and check this multiple times in order to get the weight under. Lastly, we had to work on balance. In order to have a freestanding bridge, we had to add 2 planks to each side in order to allow for it to stand. Our final test came at Fed Day. We came in confident for our bridge to hold the 150 pounds. However, it only held 115. Come to find out, we had missed 6 screws in each of the latches. And once we were fixed that, because we were not yet defeated, it held approximately 170 pounds.
This is so nervous. You know what? It's going great. Yeah, it's how they're doing it. It's community. Where are they going to put it? Where are they going to put it?
How did you do this last time? I don't know how that.
Are they not good at like... Oh, no.
It pulled the screw out. Okay.
Now that you have a fundamental understanding of how we use the engineering design cycle, we have some advice for you. My piece of advice for you freshmen starting Fed would be to use your resources. Something like the Craft Center is what we used to build our bridge. It's right here on campus, it's free, and there's tons of help there. We also used Maddie's car, for example, to go buy wood at Home Depot. You have to use everything at your disposal to make sure your project is fantastic.
My advice to you freshmen starting Fed next year would be to double check your work before you send it in for final testing.
My advice, remember to always start early.
My advice to you freshmen would be to ask for advice. While the experts can't tell you exactly what to do, they are more than willing to lead you in the right direction.
My advice to you is to not be afraid to get creative. Think outside of the box.